Hello, ACT. It's glad to be here as the opening act. So I'm Elior Fureraj. I'm an AI research engineer and consultant. I've did my studies in UCLA. I worked at Zest AI, METR, now at Retech. And I'm here to talk about, well, part of the topic. I omitted a couple of words there. But we're talking about the future. With my background as AI, you might expect I sit here and say that AI is the future and try to sell that, but I try to avoid that as much as possible. I think enough people have done that so far. And I'd like to instead take it from the viewpoint that AI is a tool. It is a powerful tool. It is one that is not very well understood and has gained a very widespread popularity in the past 3 years. So a lot of people are using it day to day and not really seeing some of the dangers that come up with it. Now, I want to put a spotlight on how these models work. I want to put a spotlight on how they can fail, in addition to how they can help us, right? So that we can treat it as for what it is, a tool, so that we know when it can fail us in the future when we need it. But beyond just talking about AI and how this is going to be a part of your life, or whatever that is your decision, right? The idea is that everything that is available to us is a tool that we need to understand, and we need to go a little bit deeper than just a surface level understanding of the tools we use. If we drive a car, it would be ideal to know what to do when it breaks down. So let's look into that. I posit that while AI is very exciting, it is a field that is changing very fast. So fast, in fact, that it's a bit difficult to keep up with the research. But there is a way to prepare for the future, to navigate it in a way that, well, would lead to success or would, lower uncertainty, and that is by curiosity. I don't mean curiosity as in what is the next model coming out, what does it do, how much better is it at a specific benchmark, can it write my essay that much better, really? I want to see it from a viewpoint of curiosity about what is happening underneath. What is actually driving the responses behind the little box on your browser that is spouting words at you. And curiosity is the mechanism by which us, will dig into a fundamental understanding, right? You need to understand how it works in order to better use it. And since I really am passionate about this topic, I'm going to go into way too much detail about how models work and how they are trained. So sorry about that. Bear with me here. Let's talk about what AI is right now. Right now, it has basically become another term for machine learning, and specifically for neural networks. So these are very simple models that, well, no, they're not very simple, but they are models where you have some input and you expect it to learn some mapping to an output, right? And in the form that we use them nowadays, as in ChatGPT, we write to it, we write text to it, we expect it to do some magic in the background, and then it's going to spout out something in return, also text, or maybe sometimes an image. Well, the way this is trained is that we have this model. With LLMs, we do not provide exactly what the output is specifically that we want to train it. The way we do it is we give it a sentence, and then we say, hey, this sentence, Mary had a, usually then like a little lamb. We give it to the model, and we say, what comes after Mary had a? The likelihood is going to be little. Right? We want the model to learn that. We want the model to understand that this is usually how this sentence ends. And if we do this enough times, if the model sees says this sentence and said, yeah, okay, Mary had a major, that's not the right word. What went wrong there? Figure out exactly how that went wrong, figure out the difference between what is the right word and the wrong word, and shift the model. Do this enough times, and it's going to learn how to answer correctly. And in a weird way, it is going to pick up concepts that are deeper than just language. It's going to learn concepts about the real world and relationships between them. And this is the cool thing about it. So this is how the model works at a very high level. The way it is trained is we take the entirety of the internet in textual form, and we are going to shove it to the model and tell it, we want you to learn this. We want you to spout back to us what you read. And it's going to do that. It's very similar to how your phones do the auto-completion, except that it's learning a little bit more, ideally. But that's not where it ends. The magic comes when you do instruction tuning, the next step in training. So we tell it, hey, okay, you are going to autocomplete this instruction. I will give you a command. I want you to respond to that in a way that is useful to me. We give it enough information on that. It's going to learn how to do that. We suddenly got a useful model. We are able to extract that knowledge that was stored within the model weights. Okay? That is useful. We can do better. We can make this more fun. We can put a conversation. We can teach it, hey, I want you to talk to me like you are a human, like an assistant. And then we train it on that. And suddenly, we can have a full conversation with an AI model, which is bizarre. I mean, we passed the Turing test. This is fascinating. And the final step, until like 3 years ago, because there are alternative ways of doing it now, but the final step was reinforcement learning with human feedback, where we taught a smaller model, hey, humans like this response compared to this response. And this little model knows, like, okay, yeah, humans really like this stuff. I'm going to teach this big LLM how to respond to me in a way that I will really, that the human will like, and we all won from this. It's fascinating. OpenAI really did well with ChatGPT once this came about. However, there are problems in each of these steps of training. With pre-training, we just took the entirety of the internet. Now, the internet is many things. It's awesome, but it's not completely factual. Far from it. So this model has learned all the truthful statements, all the falsehoods, all the biases, everything you don't want it to know is in there somewhere, and it might show up. A recent paper from OpenAI kind of showed this, despite being somewhat obvious. It was impressive that they showed this as a mechanism for why models hallucinate. And you can imagine how this might be okay if you're just chatting with it for fun, but if we're using that in medicine, like if a doctor is trying to get a second opinion from a chatbot, you would not want it to get an hallucination there. Beyond that, there is the other step, reinforcement learning with human feedback. I mean, I hope that rose a couple of alarm bells, because I don't think it rose enough alarm bells 3 years ago, where we are teaching a model what a human likes. Now, I like it when someone compliments me, even when I do stuff that I shouldn't do, or, when, well, I really shouldn't have that burger maybe, but I will have it, and ChatGPT will absolutely tell me, yeah, you deserve that. But sometimes I shouldn't, I should go for the greens. And the model doesn't care about that, and it is not designed to care about that. And now we see sycophantic behavior in action. This is particularly problematic if we take the example, and I've heard far too much anecdotal evidence of these tools being used as substitutes for therapy. I mean, how wrong can that go? There have been steps to address this so far, and ideally it will continue to be addressed, and it is something to keep in mind next time you're using it. If it's being too nice to you, take a step back, maybe push back a little bit, or don't use it for therapy, please. Right. This is the next topic that I'm really excited about, and I want to talk to you. This is about how models think, and I'm going to use that word very loosely here, because I don't want to go into the philosophy of thinking. But essentially, we have models, we feed them words, or tokens actually, and we hope that there is going to respond back with words in a way that is useful and, you know, makes us feel good, apparently. However, now there is quite some body of research that confirms the fact that these models encode the knowledge about the concepts and relations between them in a way that, well, it's not language. And some interesting papers that I have mentioned here are, well, it's tiny stories. This is a very important paper to me, which basically said, hey, we can teach a very small model, a couple million parameters, which compared to the behemoths of today, which Kimi K2 is like 1 trillion at this point, we can teach it how to speak coherent English. So a couple of million of parameters is enough for this model to learn grammar, syntax. It can kind of pass the Turing test, kind of. It can learn basic facts. So language is not apparently the very difficult task to solve. It wasn't until a few years ago. Further from that, we have another paper, separating tongue from thought. This was very interesting. You take a model that translates from one language to the other. They kind of showed that in the further layers of the model, as it is abstracting this language, in fact, the concepts are not tied to the language. So somewhere in there, it is transforming these words and these topics into representations that are abstract. It knows what a human is, and it is performing very complex computations within the weights about what that means, and what that means in relation to what humans do, or how they look like, or where they live on Earth, or I don't know, space. And the other cool thing is the layer-by-layer paper, which showed to some extent that these layers that encode these complex thoughts, well, they outperform the later layers which transform these thoughts into language, back into language. So what I want to pose here is, we have complex thoughts going on inside the model. We have tried really hard with instruction tuning to draw these thoughts out so they are useful to us, and we are collapsing them back into language, and we're losing some information there. Now, a lot of complex computation going on, we collapse it into a single word, and that single word is going to be fed back into the input. Suddenly, we lost all that information. If the collapse is wrong, if it comes up with a wrong word, if it says, hey, Mary had a big, okay, that's wrong. Now we have to keep going with it, because where do we go from this, from here? Rocket, or I don't know, tank, doesn't matter. That went way off the road. We got a hallucination here. And this also comes into being from a much simpler example that is not as cool to talk about, but it is sampling, which the model, well, the model doesn't actually output just a word, right? It outputs a probability distribution over words. It's going to say, hey, I think that in this terrain of hills and valleys, which the hills present words that are likely to be good, I think this is what's going on. You're going to have to pick one from one of these, okay? It could be little, it could be major, it could be something else. So what we do here is we either pick the highest cliff, highest hill, or we do some sampling over here. We introduce some randomness. We say, hey, let's pick the top points that we see, top 20, doesn't matter. And we do some random sampling from there. We're just going to pick one at random. This could be wrong. Doesn't matter. It collapsed. That word is going to become part of the context. That is going to lead to a completely different trajectory of an answer. So these errors cascade. And ideally, there are obviously ways to address this, and people are actively working on fixing these issues. There's another issue. I mentioned random sampling. Same question, different outputs. This is usually okay if you're brainstorming or you're trying to do creative writing. However, If you want your application to work correctly, 100% of the time, this is going to be a problem. So what do I say here? Be careful to understand exactly what is going on with the model, right? Where is this non-determinism coming from? It could be the random sampling. Address that. Figure that out. Temperature has been, misunderstood a little bit. Is it what it does? But it could also be just a bug in the code that is implementing the model. And actually, Thinking Labs from a horse head, Thinking Labs actually wrote a paper recently on that, where it just found, hey, we made a little mistake in the calculations and things don't work. Only in the cases where the server is being overloaded with requests. This is like, you can't really do much about this. And the idea is you need to understand why or how these models work in order to use them effectively. If you are an AI engineer and you want to use it in an application, you need to make sure that you understand how it can fail so that you can address it properly. Now, how this ties back to navigating the future. Very good question. If you're going to use AI, try to understand what you're using. If you don't want to use AI, that's fine. It's still a very nice tool to be around. But the important thing is try to dig deep in whatever you are using. Whatever you are actively using in your life, your car, your, computer even. Try to understand what's going on there to the extent that you have time for. Try to dig a little bit deeper so that you are ready for the future when you are faced with problems that you cannot solve or you cannot predict or you don't have time to find help for. This is critical. Understanding gives you the tools to face the future. And thank you very much for listening to my very long talk.